Welcome to Study Loop.
In problem 89 of chapter 1, Intros, Chemistry, Structure and Properties, we've been asked to determine the number of atoms in each of these samples. So the first sample is 5.18 grams. So in order to determine the number, the first thing you want to do is to determine the moles, right? And then after you determine the mole, you can then multiply that mole by Avogadro's number to give you the number of atoms. So for the first part, number of atoms in 5.18 grams of lead, essentially we have to find what the mole is. So the mole is given by the mass over the molar mass. We take the mass 5.18 grams with the molar mass of lead, which is 207.2 grams per mole. And this is going to give us the mole. So we multiply this by Avogadro's number of 6.023 times 10 to the power 23 atoms per mole. And this, you would see that the final result should be 1.51 times 10 to the power 22 atoms of lead. The second question, second part of this question is very similar to the first. You follow the same approach. So the number of atoms is going to be given by the mass, 2.26 grams over the molar mass of lead, which is 200.59 grams per mole. Multiply that by Avogadro's number, 6.023 times 10 to the power 23 atoms per mole. And your final result should be 6.79 times 10 to the power 21 atoms. Moving forward for bismuth, same idea. Take the mass, 1.87 grams, divided by the molar mass of bismuth, which is 208.98 grams per mole. Multiply that by Avogadro's number. That should yield 5.39 times 10 to the power 21. And lastly, for strontium, same idea. We would have 0.082 grams divided by the molar mass, strontium, which is 87.62 grams per mole. Multiply that by Avogadro's number. And that would give you a value of 5.64 times 10 to the power 20 atoms.